Hi everyone. In this video we're going to be working on 2015 AB Calculus AB as well as BC free response question number 3. Now, in this question, this was on the AB exam, but it was also on the BC. So remember, Calc 1 or Calc 2. So even though it says BC on the top, it doesn't matter. It was still on the AB exam. Okay? So let's go ahead and get started. Now, remember, on all these questions, you're roughly going to get about 15 minutes per question to be able to solve this, okay? Now, this is a question that shouldn't take you that long. This is one all about knowing what to do and at what steps. Now, the first thing that you're going to do is you're going to look at this chart. When you see this chart, you're going to ask yourself, what does this mean? This is a chart that they're going to ask you for area, probably. Left Riemann Sum, right Riemann Sum, midpoint, trapezoid. Okay, so what I first want you to do is I want you to take account for all of these numbers, the y values. In this case, v of t, probably standing for velocity. Probably. We'll find out in a second. But the fact that all these y values, they're going up, then going down, going up, I want you to draw that so that you have a visual of what's happening to your graph, okay? Alright, now let's go ahead and get started. So for part A, it says, the question says, Joanna jogs along a straight path from time 0 to 40. Joanna's velocity is given by a differentiable function v. Just means that you're able to derive it, which got us v, which is velocity. Selected values of velocity, where t is measured in minutes, v of t is measured in meters per minute, okay, are given in the tables above. The reason why it says meters per minute is because it's the first derivative, so it already has units. And part A says, use the data in the table to approximate, or to estimate the value of v prime of 16. What they're asking me to do for part A is they want me to find a derivative of 16. Now when you look at it, you're like, oh, that's awesome. I can find a derivative. V prime is me finding the derivative of velocity. Problem is, there's not an equation. There's only values. So what I want you to know is every time they ask you to find a derivative of a value and all they give you is coordinates or a graph, what you're actually going to do is you're going to apply the slope formula. y2 minus y1 over x2 minus x1. Well, in this case, where is 16? Well, if you notice, 16 is right between 12 and 20. So because of that, you're actually going to find the slope of the velocity. So this is how you're pretty much going to plug this in. V of 20 minus V of 12 over 20 minus 12. So pretty much 240 minus 200 over 8, 40 over 8, which this is going to give us a value of 5. Now the one thing you have to do is please put the units. Well, remember the units are meters per minute, so this is going to be meters per minute, except because since this is acceleration, technically, since I'm finding v prime, I'm going to square it. Okay? So if ever they're asking you to find the derivative and all they give you is coordinates or a graph, find the slope. Okay? Alright, now moving on to part B. Part B says, using correct units, explain the meaning of the definite integral 0 to 40 of absolute value. Well, remember, anytime you see this absolute value of v of t, that represents total distance. Okay? Total distance in the context of the problem. So the first thing that you just have to say is, for part B, because it tells you to explain the meaning of it, so for part B, it says, from 0 to 40 of the absolute value of dt, this represents the total distance Johanna jogs in meters from time between 0 all the way to 40. And that's all you have to explain. Okay, and if you're able to do that, you get 1 point. Now the next thing says approximate the value of that using right Riemann sum with the 4 subintervals indicated. 4 subintervals just means 4 rectangles. So what you're going to do is you're going to draw 4 rectangles from 0 all the way to 40. 1, 2, 3, 4. Those are my 4 rectangles. Now the one thing that you have to be very careful about, in order to solve this, what we're trying to do is we're trying to find the area of the rectangles. But because it's an absolute value, every single y value is going to become positive. If you remember that, you're going to be great in this question. So let's find the area of the first rectangle. Well, remember, right Riemann sum, left Riemann sum, midpoint, trapezoid, all has the same rule. Find the width of every single rectangle. For the first rectangle, the width is 12 from 0 to 12 times right Riemann sum is the right height of that rectangle. which is the y value 200, plus the next one, 12 to 20, is 8 times the y value of the next one, 240, plus with again 4 times, and some of us are going to put negative 220, but you can't because it's absolute value. Total distance is never negative value, so you have to put 220, and followed by the last one, which is 16 times 150. Okay? Now, the one thing is you don't have a calculator on this question, so you're going to have to do a little bit of math. So working everything out, you're going to get this. 2400, let me move this up a little bit, plus 1920, plus 880, plus 2400, and this all equals to 7600 meters. And that right there represents the distance that Joanna jogged between 0 to 40 of total distance, okay, using a right Riemann sum. Alright, so remember, anytime they ask you right Riemann sum, just draw the rectangles and you're using the right endpoints. If in case they were asking you left Riemann sum, you would have used the left rectangles, which you could always watch one of the other videos to kind of help you go over that. So now moving on to a few of the last questions. C says, well, Bob is riding his bicycle along the same exact path from 0 to 10 minutes. Bob's velocity is modeled by B of t is equal to t cubed minus 6t squared plus 300, where t is measured in minutes and B of t is measured in meters per minute. Find Bob's acceleration. Okay, well, this represents Bob's velocity, so if we want to find Bob's acceleration at time t equals 5, let's go ahead and find a derivative. Because remember, if this is velocity, acceleration is one more derivative. So technically, B prime of t is going to equal to 3t squared minus 12t, and then 300 will just become 0. So that's my acceleration equation. You get a point for being able to use that, and the last thing is be able to plug in 5. So the acceleration at 5 minutes is going to be 5 squared minus 12 times 5. And if you work all this out, you should get 15, and then think about the units. Meters per minute, except what? It's acceleration, so it's squared. Okay? And that's C. And C was a value of 2 points. One for the answer, one for the derivative. And then the last part of this question. The last part of the question is this. Based on the model of B from part C, find Bob's average velocity. Now this is a key word, average velocity. Average velocity. There's two types of average formulas. Slope formula and 1 over b minus a times the integral. This is the thing you have to ask yourself. What do they want you to find the average of? Velocity. What was the equation given to you? Velocity. So this equation represents, they want you to find all of the velocity that Bob had riding his bike. So from 0 to 10 of pretty much t cubed minus 6t squared plus 300 dt, because everything's with respect to t. But because it's average velocity, we're going to take all of the velocity that occurred, and we're going to divide it by the total amount of time, which is 10 minus 0. 1 over b minus a. Okay? How did I know to do this? Because they wanted me to take everything that Bob had in velocity and then find the average of it. So this means that we're just going to have to integrate this. So this is going to become 1 over 10 times t to the 4th over 4 minus 6t cubed over 3 plus 300t. And then bounds 10, 0. I'm going to simplify this just a little bit. It's going to become 1 over 10 t to the 4th over 4 minus 2t cubed plus 300t. And don't forget your bounds, 10 to 0. So the next step is, well, since we found the integral of this, we actually have to do the fundamental theorem of calculus, which is plugging in the upper bound minus the lower bound. Now the one thing I want you guys to notice is I have to plug in the upper bound, of course, but the lower bound, when I plug in 0 into all of it, it's going to cancel out. So I'm actually not going to go ahead and plug that in. So when I plug in 10, this is what I'm going to get. I'm going to get 1 over 10. That's a constant, leave it on the outside. 10 to the 4th, which is going to be 10,000 over 4 minus 10 cubed is 1,000. 1,000 times 2 is negative 2,000 plus 300 times 10, which is 3,000. Once again, I'm not going to plug in 0 because everything I plug in is just going to be canceled out. So I'm only plugging in 10. Now working all this out, this value right here is going to be 2,500 minus 2,000, keep it the same, plus 3,000 times 1 over 10. And if you work all this out, you should get a value of 350. Now think about it. What did we just find? 350 what? What were the units? Meters per minute. Because it was velocity. Okay? And that question was worth 3 points. So it's all about being able to find key items. It's all about recall. Think about what you have to do, what you have to find. For part B, the fact that it had an absolute value of an integral, that's total distance every single time. So when they ask you to explain it, just find the total distance of whatever that is from 0 to 40. Then the last thing that you had to know was write Riemann sum. Draw your rectangles, only use your right endpoints. And then lastly is being able to determine average velocity. Because my equation was velocity, they want me to find the total amount of velocity that occurred from 0 to 10, but then divide it by 1 over b minus a, which is the average of it. Okay, so thank you guys for watching. I hope it helped, and let me know how it went.